Yeah, that's perfect. That's perfect. What is up, AP? Well, no, not AP stats. Good night. Do I need to start over with this? It's been one of those days, Hannah. We'll just keep rolling. Pre-Cal 12. This is you. This is for your homework here, and we're gonna get started. I just wanted to answer some questions with me not being here tomorrow, and so let's get it going. And let me unfreeze this because that's a good idea as we get underway. So let's go. The first question we were going to go through is the zeros. This one up here, number 3. Is that it, or one of these down below?
It was 4A.
It's perfect. Let's do it. Let's go 4A. Let's go through each part of it, okay? Because I think some people even at home are probably like, yeah, this is a good one to go through. Number 1, or 4A, part 1, apply the lead coefficient test. Well, first off, we need to know, okay, is the lead coefficient, is it positive or negative? And then also, what is the degree, right? First off, we look at this and we see something that is squared, something that's to the third, and we know it's factored, right? This is, by the way, this is not in standard form. The top one is in standard form, right? So it's easier to find the lead coefficient of this because it'd be positive, even, right? So we would go from there. But here's a little tougher because you got to think in terms of if I'd multiplied this out, what would be the highest degree? And we know that the highest degree would be 5. Good, because it would be 2 of them and 3 of them, making it x to the 5th. Okay. Now I don't know what's going to be in front of it. Well, actually, I could probably have a pretty good idea. But all I need to know is whether it's positive or negative. And we know it's going to be what? Positive because of the 110. So we're going to say that this is positive x to the 5th. And so the lead coefficient would be positive. The degree would be odd, which tells me that what are we doing? Upright and down left. So we'll rise right and fall to the left. Okay? Good. Part B, find the zeros of the polynomial. And we could find the zeros since it's already factored by just setting it equal to 0. And we know that what would be the zeros here?
-1 and +3.
Good. So it'd be -1, 0 and 3, 0, right? What's the multiplicity of each?
1. Or no, 2, sorry. 2 for -1, 3 for 3.
Good. And we remember multiplicity based off of the exponents, right? And we also remember that since the multiplicity, I think we've done A and B, right? Since the multiplicity is even, it will do what at that 0? So like this is at -1, 0. It's going to bounce here, right? So we're just going to put maybe a B here. You could even say bounce. Whereas at the odd, at 3, it's going to go through. It's going to cross. Yeah, good. Now again, we're going to rise right, and we're going to fall left, right? Okay? So again, we don't know what's in the middle here yet, but we do know what the end behavior is, and we do know our zeros, and we also know whether it's bouncing or whether it's crossing. Okay? All right, so how do I approach this? Well, I'm going to backtrack just because I don't want to have that circle in there. Good. Okay, so we start here. We go upward, right? And what happens at this 0? Good, it's going to bounce here, okay? And what's going to happen at this one? It's going to go through. Now, as I notice that it bounces and goes through, we see that, but the question is how low do I go, right? Now, 2 options. Number 1 is I could go and pull up my calculator and find the minimum down below, right? So second trace, plugging this in, and then just find what that would be as the minimum. Another option is coming pretty close by plugging in a value that's between or close to the middle between -1 and 3. So maybe we could just make a t-chart here when it says plot sufficient points. We could maybe plug in 1 and maybe even 2 in to see what we get out. I think 1's going to be sufficient. So as we plug in 1, we get 1/10 as we plug in for x. 1/10 times 1 plus 1 being 2. 2 squared is, yep, that's exactly right. Plugging in 1 in for x over here, 1 minus 3 would be Good. And then cubed would be
6.
negative
Oh,
8, right?
negative
Because
8,
we
sorry.
multiply
Yeah.
on that spot. Good. Okay. So now we've got 1/10 times 4 times negative 8. And what we can do, and I'll get a calculator here, we can multiply this. 4 times negative 8 is good. Negative 32 times 10 would be about, 1/10 would be negative 32 over 10, which would be like negative 3.2. I'm throwing it out there, okay? So negative 3.2. And again, you'll have a calculator to find that out, right? So I think you do this, go to 1 and go down to negative 3.2, about right there. Hold up, where am I? There we are. Negative 3.2, and there I am. And notice it's not exactly, actually, is it? I think it is exactly in the middle right there. So that means that actually that would be my minimum right there, 1 comma negative 3/2, because it's exactly between negative 1 and 3. Okay? And then we could just draw that out, and there's your graph. Okay?
Thank you.
You're welcome. Thank you for staying. Those of you at home who need a little bit of extra help, just as a heads up, if you look at Part A is a good one too, finding the real zeros. Maybe this would be of help to you. Zeros is where I plug 0 in for y, or in this case f of x. And well, then I'm going to just pull out what's in common. So I can pull out an x squared, leaving me with x squared minus x minus 20. And then I could factor the inside to x minus 5x plus 4 with an x squared on the outside. And my x-intercepts would be 0, 5, and negative 4. And it says determine multiplicity. The number of turning points is intriguing because if you think of a quadratic, and I'll do it down here, a quadratic is, see Hannah, something that has x squared. Well, something that is squared has one turning point, meaning I come down and then I go back up again. The amount of turning points that could occur on this graph would be whatever the degree is minus 1. So just like this would have one turning point with a degree of 2, this would have turning points would be possibly 3. Okay? And then you could graph use the graphing utility to graph there. Okay. Go ahead and try B. Try B out. The only other one that I remember seeing that might be kind of tricky is it's off this homework here. 2.2a. Let me see. I think this is it. I'll kind of pull this up. Yeah, this is it. Okay, so just as a heads up here, I think we did this one in class, so check that out on the podcast if you missed it. Over here, this is a basic quadratic. My idea of this would be taking out or factoring out a negative value and then kind of factoring from there, finding the zeros set it equal to 0. But many times this is going to be like your traditional quadratic. Down below, it says use a graphing utility, determine multiplicity of each graph. Remember, if it bounces, right, at that 0, in fact, I want to just kind of show this. Let's actually show this one. I think y'all are good at this one over here. As that's coming up, another thing to remember is as we go up here to these ones, make sure that you plot sufficient points on this one. And it also make sure, let me clear this. We want to also make sure that like this one, normally we rise right, fall left, but because it's negative odd, it's going to rise left and fall right. So just plot the points there and remember the transformations that are needed on that specific one. Okay, let's go over here. Let's just put in 1/4 x to the 4th. So we'll put parentheses 1 divided by 4 x, put x right here, to the 4th minus 2x squared, I think it is. Okay, so it did say to use a graphic calculator. Okay, so go to graph. It might look kind of weird if it's anything like mine here. Probably looks kind of strange, or you don't even see it at all. So go ahead to zoom standard. I always start there just to see if I can see it, and in fact I can. I noticed that it crosses here and here, and then here. Obviously it touches and it looks like it bounces. So we want to find the x-intercepts. So to do that, we're going to go to second trace, 0. For this one, it touches at 0. Notice you won't be able to find that on a calculator because right here it doesn't actually cross it. But there is an x-intercept at 0, but the multiplicity would be, yep, you guessed it, would be 2 because it bounces at that spot. Whereas these multiplicities would be 1, has to be odd because it crosses. So we'll go left bound, right bound, guess, and there you are, negative 2.83, comma 0. Do the same thing on the right side by going to second trace, go to 0. And remember, we're going right bound. See if we can pull forward. Left bound, right bound, and then guess right in between. There you are, 2.83. That's it. Okay. All right. Hey, I hope that's helpful for you. Just a quick podcast over that homework. Hope that was helpful. And check out the other podcasts if you have any questions on anything. See y'all. Bye.